Hi, my name is Mike Forder, and I'm the AS&T Corporate Level 3 for AltaVista Solutions, and this is part of a video training series. Today we're going to be demonstrating how to properly set up a distance amplitude correction curve using ultrasonic shear waves. Okay, so what we've done is we've set up a USN 58. It doesn't really matter which particular scope that you have. They're similar. The functions will be a little bit different. And for this demonstration, we're using an AWS transducer. It happens to be cycling at 2.25 megahertz. And then we also have a mild steel calibration block, and it's specifically called a NavShip block. So it has 60 thousandths diameter holes at varying depths. So what I'm going to do is I'm going to start on the second hole that is at a 1/2 inch in depth. And then we'll walk through the scope and how to set the DAC curve up. So we got a little bit of couplant on here. And we're going to maximize the signal. We're going to run this back and forth till we can find the peak of the signal. And for most of the scopes of today, you have to make sure that all your indications, whatever you want to do, you have to make sure that they're inside the gate. So in this case, I happen to have the gate set at 40% screen height. So I'm going to go into in this particular scope, it's a next button, and it says TCG, which stands for time corrected gain. So we're going to go in that particular menu. So, and we're going to go into the record. So we're going to set the maximized signal. We're going to come over to record points, which is in this corner here. We're going to record that first point. And as you can see, when you press it again, what it does, it says 1 point is recorded. So we've recorded the first point of our DAC curve. So I'm going to back up. I'm going to get the next hole, which is at about 3/4 inch in depth. And I'm going to maximize that signal. And then I'm going to go back to the menu, and I'm going to record that particular point. And as you can see, as soon as I hit that, it started to develop the DAC curve. So, and that's the trace there that we see on the screen. In older days, you would have to draw this on the screen itself with a grease pencil, but with the digital technology today, you can do it right in the screen. So I'm going to back up, and I'm going to go to the next hole, which happens to be at 1 inch in depth. And we're going to maximize that signal right about there. And I'm going to record that point. And there you can see that it did that. So you have to have, recommended to at least have 3 data points for your DAC curve. So at this point, I'm going to hit the finish button. And what it did is it converted it into a time-corrected gain. So the difference between a distance amplitude curve is it compensates for your sound the deeper you go in the metal. As you notice that at a 1/2 inch in depth, I had a much stronger signal, little less at 3/4 inch, and even less still at 1 inch. Time-corrected gain brings all these particular signal strength up to a known value. So in order to transfer over to a DAC curve, we're going to just switch it to DAC, and there you see the trace. So if we go back to that, our hole at a 1/2 inch, this is our signal strength. 3/4 inch is right there. And then at 1 inch is right there. So typical codes, what they will do is they'll have a 0 offset or a Dac offset for acceptance rejection criteria, and typically it's 6 dB. So from earlier training sessions, we see that if we change the decibels by 6 dB, if we increase by 6 dB, we increase the signal strength by twice. If we decrease it by 6, we decrease the signal strength by half. So these indications, if they're at 80% of this screen height, if we reduced it by 6 dB, it would go to 40% screen height. So how we do that is we go into the next setup, and in the next menu, it talks about a Dac offset. And what this DAC offset does is it will change this curve depending on how many dB that I happen to put in the offset. In this case, I'm going to put it as 6 dB offset. And as you can see, it's changing each particular DAC curve. There we go, we're right at 6 dB. So, and they'll call this reference sensitivity or acceptance sensitivity level or disregard sensitivity level. And it just means that if I have something that breaks this gate, it's an automatic reject no matter what the distance is, no matter how long it is. If it's between these two particular DAC curves, it may be rejectable if it's past a certain length, say 3/4 of an inch, for example. If it's beyond 3/4 of an inch in length and the signal height is in between these two, then you would reject it. If it's less than that then in length, then you would accept it. And then we have a disregard level that is down here. So any indications that come up on the screen underneath this DAC, we would just disregard, doesn't matter how long it is. At this time, this concludes this video training session on how to set up a distance amplitude correction curve. Thanks, and have a great day.